Hello and welcome in this new how-to video. Today, we will see how to use the Biosignalsplux multisensor platform in RTMaps. Biosignalsplux is a versatile multisensor platform for acquiring medical-grade biosignals in R&D projects and applications. With Biosignalsplux, you can acquire more than 20 biosignal sensors for your projects. Thanks to the Plux team, we get a nice biosignals sensor kit for this demonstration. You may take a look at the complete list of available sensors in this kit in the video description. First, we need to place the sensors on the test subject and connect them to the Biosignalsplux. Now, let's start with RTMaps. In RTMaps, we load the RTMaps Plux package. Then, we can drag the Plux component on the studio. The Plux component scans for available devices and sensors for a few seconds before appearing. Once the devices are found, the component creates the corresponding outputs and properties. Here you can see the properties for each sensor connected to the Biosignalsplux. Let's plot each sensor output against time thanks to the oscilloscope component. We can change the oscilloscope window title through the component's properties. Now, we will add a simple processing task to turn on a lamp widget when the Electromyography sensor detects a muscle contraction. First of all, note that measurements are grouped into sample packets within RTMaps data samples. Let's keep only the first sample of each packet, with a devectorizer component. We then filter the value through the bypass component with a special action. When the input decreases, the bypass keeps outputting the maximum value, until the timeout is reached. The condition component applies an if statement on incoming data samples. We configure it to produce 1, when the filtered EMG value is greater than 36,000, and 0 otherwise. Finally, we create an LED component that will turn red when its input receives 1. We can now connect all the components. Next, we register the RTMaps Webcam package and create a Webcam component. We can choose which camera to use and the image resolution. We create an image viewer that will display the video in real time. Eventually, we can configure the diagram for data recording. We create a recorder component and connect it to our components. When we do, we can choose the recorded file formats depending on the incoming data types. Here, we choose CSV files for the biosignals and AVI data format for the webcam video. That's it. Our RTMaps application with Biosignalplux sensors has been designed and configured in just 3 minutes. Now we can start the application and record the streams. First, let's arrange the windows to our liking. Then, click on the oscilloscope's auto set buttons to adjust the plot window to fit the data ranges. Notice the Electrooculography values when the eye is directed up or down. The LED turns red when the arm is contracted. You can see the corresponding change on the Electromyography plot. Now, let's shut down the application, stop the recording and play back the data. We remove the acquisition and recording components and replace them with a player. The player can be created by drag and dropping the rec file created by the recorder. Let's connect the player to the visualization components. We can now run the application. In the VCR, we can use the timeline to directly access a point in time. We can also pause the time or use the time wheel for finer time movements. We hope you enjoyed this video tutorial which explains how to use Biosignalsplux sensors with RTMaps. Please subscribe to not miss the next tutorials with new sensors.